How was the energy conservation principle discovered? Imagine a world where energy just disappeared after doing work. That would make everything unpredictable. Luckily, scientists realized that energy doesn't vanish. It just changes form. This idea didn't come from a single moment but from many observations over time. In the 1600s, scientists like Christian Huygens and Gottfried Wilhelm Leibniz noticed that in collisions, something besides momentum seemed to stay the same. Leibniz called this vis viva, which is an early way of thinking about kinetic energy. In the 1700s, people believed heat was a fluid called caloric, but experiments started to challenge this idea. Count Rumford saw heat generated during cannon boring, and Sir Humphrey Davy melted ice by friction. These experiments showed heat could come from mechanical work, not just a fluid. This was a big clue that heat and work might be connected. Then in 1842, Julius Robert Mayer, a German doctor, proposed that heat and mechanical work could be exchanged. He suggested that energy is conserved, meaning it cannot be created or destroyed. His idea was based on observations of how the body used oxygen and produced heat. Mayer's work was important because it linked heat and work as different forms of the same thing. At the same time, James Prescott Joule was doing experiments to measure how much mechanical work could produce heat. His famous experiment involved a paddle wheel turned by falling weights. When the weights fell, they lost potential energy, which turned into heat in the water. Joule showed that the energy lost from the weights was equal to the heat produced. This was strong proof that energy is conserved. Hermann von Helmholtz also played a key role. In 1847, he created a broad theory that combined earlier work and explained that energy conservation was a fundamental law of nature. By 1850, the phrase law of conservation of energy was used by William Rankine, and the idea became widely accepted. This discovery was not just about one person or one experiment. It was a series of findings that replaced old ideas and created a new understanding. It showed that energy can change forms but never disappear. This principle is the foundation of the first law of thermodynamics, which tells us that in any isolated system, the total energy stays the same. Knowing this helps us understand how engines work, how our bodies use energy, and how energy flows in everything around us. It made science more predictable and opened the door for all kinds of technological advances. The discovery of the energy conservation principle is a story of many minds working together to reveal the consistent rules that govern our universe.